Good morning, everybody. We are in our chapter on using trigonometry to solve triangles, and we've been working with oblique triangles, which means they are not right triangles. So remember that. If we were working with right triangles, we'd be using Pythagorean theorem and SOHCAHTOA, the 6 trig definitions. But because these are oblique triangles, we right now have learned how to use law of sines to find missing sides and missing angles. Well, today we're going to develop another law, and it's obviously called the law of cosines. And the law of cosines is also a rule, a formula, that will help you find the missing side or the missing angle of an oblique triangle. So again, I just don't want to just give you, hey, here's the rule. Let's develop where it came from. So it starts from the same premise as the law of sines. We take an oblique triangle, we label the angles ABC, we label the sides ABC. And if we want to find any of these sides or missing angles, we have to go back to what we already knew, right triangles. So we could drop a height and altitude in this oblique triangle. There's our height or altitude, and we know that's perpendicular because when you go to the doctor and you stand up tall to get your height measured, you're perpendicular to the ground, you have 90 degrees. So now we've broken this oblique triangle into 2 right triangles, and I'll just call that H for height. Okay, everybody? So from here, we started with our definitions. Now, in this picture, they decided that the length from A to C is broken into 2 parts. This little segment here and this big segment here. So obviously, all the way across, we know this is side B. From A to C is side B because it's opposite angle B. But we can't call this part B and this part B because the whole thing is side B. So let's call this little part here X. And let's label this point. Let's call that D. So if A to D is X, how can we represent in algebra D to C? Well, think about it. Let's put some numbers in. If the length all the way across was 10, and you knew the length here was 4, then you know the length here would be 10 minus 4, which is 6. So if we're going to label A to D, the length of A to D, X, let's label the length from D to C, B minus X. The whole thing, the whole length, minus this piece. Okay, does that make sense? From this, they're going to develop an equation. So they took the small right triangle, triangle ADB, and they said, all right, there's 3 sides labeled. Let's do Pythagorean theorem. So x squared plus h squared equals c squared. Do you all agree with that? Okay. Well, now what they did is they said, okay, let's take the big right triangle and do the same thing. We know have the 3 sides labeled, and we know to find 3 sides in a right triangle. Let's do Pythagorean theorem. So they're going to take this side, b minus x squared plus h squared equals a squared. So what we're doing is writing a system of 2 equations, just like we did when we developed the law of sines. All righty? Is everybody with me so far? Now, because we have a system of 2 equations, we need to put these together. So if you look, they both have an h squared in common. So there's 2 ways to put a system of equations together. We either could do substitution or we could do the addition method. Does that sound familiar? It doesn't matter to me which way you do it. Okay? So for this example, we could say, okay, we could line these equations up. And to do the addition method, we know one of the variables has to cancel. Suppose we want this h to cancel with this h squared. So we'd have to make this one negative. So let's just distribute a negative across. Let me get a different colored marker here. Make that negative, that term negative, and that term negative. And we know we can do that in algebra because when you multiply by -1, you keep the balance of the equation. Okay? So now what we're going to do is collect our like terms. We're going to say, okay, this is x squared minus b minus x squared. The h squares are going to cancel because a positive h squared and negative h squared cancel out. And this is going to equal c squared minus a squared. So all we did was take our two equations and using this time addition, put them together. Now, we're going to simplify. So we know squaring means to multiply this twice. So I have x squared minus, this is b minus x times b minus x. All right? We're going to distribute that out. B times b is b squared. B times negative x is negative bx. Negative x times b would be negative xb, which is the same thing as negative bx. And a negative x times a negative x is a positive x squared. Okay? So algebraically, we then distributed that. All right? So now, what can we do next? Well, now we got to get rid of the parentheses. All right? So to get rid of the parentheses, we're going to have to distribute that negative 1. All right, so I'm going to go up here. Okay, so everybody look. We have the x squared. This is going to become negative b squared, positive bx, negative x squared equals c squared minus a squared. Okay? We should obviously collect like terms. Well, what's going to happen to the x squareds? They're going to cancel out. Okay, everybody with me? And we have negative b squared plus bx, and plus bx is plus 2bx equals c squared minus a squared. All right, everybody good so far? Everybody's with me? All righty. Now, from here, because they're trying to call this the law of cosines, we obviously want to get the function cosine in this equation. So you're probably saying, well, how do they do that? How do they just throw cosine in this equation? Well, what they did is they went back to the right triangles and they went to triangle ABD. So triangle ABD is the smaller right triangle. And they picked the acute angle A. Okay, they picked that acute angle like we did with law of sines. And they, instead of doing sine, we're going to do cosine. So if this is our acute angle, we know cosine is adjacent over hypotenuse. This would be the adjacent side. This would be the hypotenuse. So I'm just going to write that. The cosine of angle A, because that's what angle we're doing with, adjacent side is x, and the hypotenuse is c. And then they cross-multiplied, and they got x equals c cosine A. So what happens is, knowing that fact, now they can replace this expression where there's an x up here, which means it would go right there. Make sense? Okay? So we have negative b squared plus 2b. We're going to substitute for x, what we just found, c cosine A equals c squared minus a squared. Is everybody with me? All righty. Great. All right. Now, we're almost there. This is almost looking like the law of cosines. Okay? So what they're going to do, and remember, this is this is them formulating a new definition, a new formula. They decided, the mathematicians decided, okay, they wanted to get this a squared alone. Okay? You can get any of the variables alone, but let's say they wanted to get this a squared alone, and they wanted to make it positive. To make that a squared positive, they're going to move it over to the left. So that's the variable they wanted to isolate. They just decided that. So they wanted to move a squared over. So they had it a squared equals. If they want a squared equals, they need to move both of these terms over to the right. So to move the b squared over, if it's negative, they're going to make it positive. They're going to leave the c squared. To move this term over, it's positive, they're going to make it negative. And ladies and gentlemen, That is the law of cosines. That is the formula for law of cosines. A squared equals b squared plus c squared minus 2bc cosine A. Now again, you don't have to memorize the development of the formula. I just wanted you to know where it came from. I didn't want you to think I just pulled it out of a hat. Okay? The thing about this formula is, remember, the mathematicians that were working with it decided they wanted to isolate a squared. They didn't have to isolate a squared. They could have got b squared alone, or they could have got c squared alone. So in your notes, this formula is written 3 ways. Don't memorize all 3 ways. Memorize one. This is the form I memorize it in because it looks like Pythagorean theorem. Okay? A squared, b squared, c squared. Now, what I want you to notice about this formula, there's a pattern. This is the side A, so this has got to be angle A. So, for example, if you were going to use this formula and you wanted to work with find side B, you'd want this to be b squared equals. Well, guys, if this starts out with b, then that angle would be cosine B. So this side that you begin with that you're trying to find always matches this angle. That means these other 2 sides, these variables have got to be the other 2 sides. So if this is a squared equals b squared plus c squared, then this could be b squared equals a squared plus c squared. Okay, you can only use each side once. If you look, whatever these 2 sides are that are being added are the 2 sides here that are being multiplied. So if I was doing this formula where I want to find b squared, I would have a squared plus c squared minus 2. I would use these sides to multiply ac. So that's another way to write the law of cosines. The third way to write the law of cosines. Suppose they didn't want to solve for a squared or b squared. Suppose they want to find side c. Then we would want to start the law of cosines out as c squared. So if we started out as c squared, we would let it equal what 2 sides we'll be using here. That's right, a squared plus b squared minus 2. The 2 sides that we multiply are these 2, so that'd be 2ab. It's the law of cosines, guys, so we're using, obviously, the trig function cos. And the angle here matches the side you're looking for to find. So that'd be cosine C. So all 3 of these are forms of the law of cosines. Just memorize one and understand whatever side you're starting with is the angle that you're ending with here. The other 2 sides go in the middle, and that's the 2 sides that get multiplied. Okay? Now what we're going to do is learn when do we use the law of cosines and actually how to use it. All right, so let's look at example 1 in our notes. So let me erase all this. All right. Okay, so example 1 in our notes says, solve the triangle. I know you're so excited to keep hearing that. Solve the triangle. We all know solve means to find all the missing parts. So, in example 1, if you look closely, that's the information you're given. Little a is 3, little b is 5, little c is 7. Well, obviously, these are sides. So we're given 3 sides. We have not been given 3 sides yet. If you go back to law of sines, we were given an angle, a side, and an angle. We were given an angle, a side. And we were given an angle, side, the bad word. So we've not yet been given 3 sides. So the first rule is, when you're given 3 sides, you have to use law of cosines to start solving. Now, you're probably saying, why can't I use law of sines? Well, let's look at our picture. Let's draw an oblique triangle. Let's label our sides, 3, 5, 7. If you thought you were going to find a missing angle by using law of sines, here's your problem. You know law of sines is A over sine A equals B over sine B equals C over sine C. All right, you would want to decide to do law of sines to pick 2 of those fractions. We've talked about it. When you decide to do law of sines, the first fraction you use is the one where you know a side and an angle. That's given. Everybody look at your picture. Do you know both a side and a corresponding angle that's given? That's the problem. You don't. You don't know any of these angle measurements. So that's why we can't start solving using this law. We could put the side up there, but we have no angle. So that's what the problem is. So that's why we need the law of cosines. So you need to memorize, if you're given side, 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 the SSS pattern, you will always begin solving with the law of cosines. Always. Now, it is important when you start this law, what order you proceed in. So in your notes, look very carefully. It says, when you have the SSS pattern, you must find the largest angle first. If you do this in the wrong order, you're going to get the wrong answer. Okay? So mathematically, if we're trying to find the three missing angles, because we have side, 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 the rule is you must find the largest angle first. So guys, how do you know who the largest angle is? Well, we've been discussing this. The largest angle is always across from the largest side. So if I look at my diagram, 7 is my largest side, so angle C is going to be my largest angle. If I want to find angle C first, how do I decide which way to write law of cosines? Very simple. If I want to find angle C, C's got to be at the end of the formula, which means it's got to start out with side C. So that's how I decide. So I'm going to use C squared equals A squared plus B squared minus 2AB cosine C. Now it's just substitute time. C is 7, so that's 7 squared. A is 3 squared. B is 5 squared minus 2 times 3 times 5 cosine C. Everybody's good? Arithmetic. 7 squared is 49. Now, 3 squared is 9. 5 squared is 25. Negative 2 times 3 is negative 6. Negative 6 times 5 is negative 30. Cosine C. All right, here's the first boo-boo. Y'all jump the gun and you start going 9 plus 25 minus 30. You cannot put all three of those numbers together. You could put the 9 plus 25 together, and that makes 34. But you cannot subtract the 30, because it's not subtracting 30. It's subtracting 30 cosine C. So think about this, ladies and gentlemen. If I had written in algebra, 9 plus 25 minus 30x, could you put all three of those numbers together? No, because that term is not like these two. These are numbers. That's a variable, an algebra expression, a monomial. So that's what you got to be careful of when you use the law of cosines. We can't subtract the minus 30. It stays because it's connected to cosine C. That's a monomial. Okay, so who are we trying to solve for? Well, we're trying to solve for C. So we got to start moving numbers to the left. So I'm going to move the 34 by subtracting. 49 minus 34, okay, I know that's 15, equals negative 30 cosine C. We're trying to get C isolated. So now we're going to move the negative 30 by division. All right, and we all know 15 over negative 30 would be negative a half. So I'm going to come up here. I'm going to write it in the order I want to see it. Cosine C equals negative 1/2. So now we're back again. What do we do to find a missing angle in trigonometry? Well, the first thing we want to do is convert that fraction into a decimal. So cosine C is negative 5/10. The only way for you to get this angle measurement out that you know how to do right now is to use your calculator. Okay? We're going to want to angle our calculator in degree mode because in this whole chapter we're working with degrees. So let's go to our calculators, our buddies. All right, so let me turn it on. Okay, good, my 30 is in degree mode. Let me turn it on. Good, my pro is in degree mode. Remember, to get an angle out, we don't hit cosine, we hit the inverse button. So on the 30, we have to go second cos, and then we put our baby negative and our decimal point. And here comes our angle. Oh, that's a nice whole number, 120 degrees. Wonderful. On our pro, we double click. We don't want cos, we want the inverse. The inverse means it's going to give us an angle. We put our baby negative, we put in our decimal, we get the same thing. Awesome. So now we found angle C is exactly 120 degrees. Okay, isn't that great? Easy formula to work, not hard. Okay, so we got angle C, but we're not done. We still got to get angle A and B. Well, the question is, do we still have to use trig or can we use geometry? No, we can't use geometry yet if we only know one angle. Okay, so we got to find another angle. Okay, it says in your notes, you can find either remaining angle. It doesn't matter now who you find next. So it doesn't matter now. Once you get the biggest angle, it doesn't matter if you find angle A or B. It's your call. I like to go in order, so I'm going to find an angle A now. All right? So to find angle A, you don't have to use law of cosines. Now you can go back to using law of sines because you now have this angle C, which you know is exactly 120 degrees. It's not a rounded answer, it's an exact answer. So now you can use law of sines because you have a side and an angle. You have a side, you're trying to find an angle. And you must have to agree with me, law of sines is quicker to use than law of cosines. So to find angle A, I'm going to use 3 over the sine of angle A equals 7 over the sine of 120 degrees. So I use my A's and my C's. I'm going to cross multiply. 7 sine A equals 3 sine 120 degrees. I'm going to divide by 7. Sine A equals 3 sine 120 degrees divided by 7. I don't have a choice. I got to go in my calculator, get out a decimal value of that. So let's go to our calculators. We'll type exactly what we wrote. 3 sine 120 divided by 7. Same thing. 3 sine 120 divided by 7. Make sure you're closing your parentheses around your angle measurement. So we all see we got the same decimal value? Good. I'm going to write that up here. So the sine of angle A is the decimal. I'm going to write the whole thing. All right, are we done? No, we want to find actually angle A. So now we have to use our inverse button. Okay? So we're going to need our calculator. All right, let's go sit back down. So remember, you have to type that whole decimal in. So now we're going to do second sine, and we're going to type that whole decimal in. Just take your time. And here comes angle A. And remember, it's a decimal number, so that must be decimal degrees, DD. I'm going to do it on the pro. Oh, I hit the wrong button. Second sine. We're going to put in our decimal. Let me get my whole decimal here. 53744. All right. We get the same angle measurement. Okay, everybody's good with that? All right. Now, you better read your directions. Okay? Every set of directions is different. They may want the angle to the nearest whole, nearest integer, nearest degrees. They may want it to the nearest tenth in decimal degrees. They may want it to degrees, minutes, seconds. Okay? For this example, let's just do it to the nearest decimal degrees, to the nearest tenth. So if I look at my decimal, I have in the tenths place a 7. Behind it's an 8, so this would round out up. So this is approximately 21 8/10 degrees. Okay? If it asked it for DMS form, then you would have to change the decimal degrees to DMS by doing your DMS button. Okay, so read your directions. Are we done solving? No. We have angle C. Now we got angle A. So what's left to get? Angle B. And if we know two angles, To get the third angle, we can use good old geometry. We add them up and subtract them from 180. So to get angle B, we know we have a triangle is 180 degrees, and if we subtract the 120 and we subtract the 21 and 8/10 degrees, we know angle B would be 38 and 2/10 degrees. Now, you could find angle B by doing law of sines and doing side B over angle B, side C over angle C, but it's going to give you the same result. All right, is everybody good? All right, let's do one more example with law of cosines, okay? This one is a word problem. Okay, so let me erase. All right, so everybody look at your notes. Read your word problem. Okay, two roads intersect at an angle of 102 and 1/10 degrees. Your friend's mailbox is 476 feet from the intersection, and your mailbox is on the other road that's 615 feet from the intersection. How far apart are the two mailboxes to the nearest foot? All righty, so we're going to have to draw a picture. So that's the problem with applications. There's a word problem. You can't even go begin solving this until you see a picture to see what pattern you have. All right, so it says two roads intersect. So intersect means we're going to come together. And the angle is obtuse because it's 102 and 1/10 degree. So I know I'm going to draw an obtuse angle. Okay? Do you agree those intersect? All right. I'm labeling it. Your friend's mailbox is 476 feet from the intersection. This is the intersection. So your friend has a mailbox over here. And you know that's 476 feet away. Your mailbox is on the other road. So it's not on the same road. It's on the other road. Your mailbox is over here. And your mailbox is 615 feet away. And the question is, how far apart are the mailboxes? Well, that's your friend's mailbox. That's your mailbox. How far apart is this? This is what we want to find the distance of. Okay? Everybody's good with the picture? So now, look, you don't get to go eeny, meeny, miny, moe and decide, do I want to use law of sines? Do I want to use law of cosines? You have to look at the pattern of the information given. So let's look at our pattern. This pattern is side, angle, side. And if I go from this way, it's side, angle, side. Doesn't matter which way. If I go counterclockwise or clockwise. This pattern is side, angle, side. Well, have we used this pattern with law of sines? No. Law of sines is always angle, side, angle, angle, side, or ASS. That's when you know to use law of sines first. So law of cosines would either be side, 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 or this pattern, side, angle, side. So that's what you're going to have to memorize. You're going to have to memorize which pattern goes with which law. So we have the side, angle, side pattern. We're always going to use law of cosines first. Now, if we want to find this missing side, let's put some letters. Okay, I don't care if you call that side A, side B, side C. Just for giggles, I'm going to call it C. That's side C. This is angle C. That means one of these sides is A and one of these sides is B. Okay? I just like to label everything. So the thing is, if I want to find the length of this missing side, I'm asking you to find side C. So when I write law of cosines, it's got to start out with what letter? That's right, letter C. So we're going to write C squared equals A squared plus B squared minus 2AB cosine C. Make sense? I want to find side C. This angle's got to be the same angle. It's got to be the corresponding. The other two sides are here in the middle. They're in the middle here connected by multiplication. Now let's see if we can substitute. C squared equals, my A is 476 squared. My B is 615 squared. Minus 2 times 476 times 615 cosine. Do we know angle C? Yep, we do. 102 1/10 degree. Everybody's with me? Now everybody look, who are we solving for? We're solving for little c. It's already isolated. So guys, everybody on the right side are numbers. You don't have to type this in separate pieces. Your calculators are so smart. You could type this whole right side in one swoop and get out a number. So let's sit down and do that together. Let's go slow and type that in our calculators. All right. So let me clear this out. So to type that in our calculator, what you say is what you type. So we're going to type 476, and we're going to hit our square button, plus 615. We're going to hit our square button. Now we're going to do the minus sign. It's not the baby negative. So the minus sign is right here, subtraction. Minus 2. We're going to open parentheses, put our 476 and close it to show multiplication. We're going to open parentheses, put our 615 and close it to show multiplication. Then we're going to hit the button cos, and we're going to do 102 1/10 degree and close it. Remember, we're in degree mode. We don't need the degree symbol. All we got to do is hit equals, and there comes our big decimal. So just take your time typing. So I'm going to write up here now, c squared equals. I'm going to write that whole decimal down. Are we done solving? No, we don't want c squared, we want c. How do you get rid of a square? Very good. You square root the left, you square root the right. So now we're going to square root this big decimal. So we're going to go back to our calculator. Remember, your square root button is above your square button. Even on the 30, x2s. Here's your square button. Your square root button is in blue. So every time you want the square root button, you have the second square. So let me pull that back up. So now I'm going to hit second square root, type in the whole decimal. Do not round till you get to the very end. If my calculator opens a parentheses, I should always close it. That's telling the calculator, yo calculator, all these numbers are underneath the square root symbol. And there's my exact answer. So I'm going to write my exact answer down. And then we're going to read directions. It says how far are the mailboxes to the nearest foot. The nearest foot would imply the nearest whole number. So I have a 2 in my ones place. There's a 9 behind it. So this would be approximately 853 feet. That's how far apart the mailboxes are. Is everybody okay? Now, if they asked you on this word problem, once you found the missing side, to find the angles, there is a rule. Okay? So with the SAS pattern, you're always going to find a missing side first, always. Then if they ask you to find another angle, it matters which angle you find first. And in the notes it says, when you have the SAS pattern, you find the smaller angle first. So if we were going to go find the smaller angle, who would be the smaller angle? Would it be the angle formed with your friend's mailbox? Or would it be the angle formed with my mailbox? Well, from geometry, we know the smaller angle is across from the smaller side. So if they asked us to find the angle, and we had to find the smaller angle, we'd have to find this angle first, because this is across from the smaller side, 476 feet. And to find that smaller angle, we wouldn't have to do law of cosines again. We could do law of sines. So I'm going to show you that. Suppose they asked you to find that angle, okay? To find that angle, it would be quicker to do law of sines. So you have that side, 476, and you want to find that angle. And I'll call it theta. Now, you have this angle, which you know is exactly 102 1/10 degree. You also have this side. So the question is, we've talked about this before, when you use this side, Do you use the rounded version, the 853 feet, or do you use the exact? You should always use the exact, and that's a big deal. If you use a rounded answer to get to the next answer, it's going to be off. So we want to use this rounded answer. And then we want to cross multiply, okay? And that's in your notes to follow along with. So now we know how to solve an oblique triangle with all the different patterns. We know we have two laws, law of sines, law of cosines. The patterns tell you which law you have to start out with first. If you start out with law of cosines, you only need to use that once, and then to find everything else, you could use law of sines and geometry. Okay, we have one more thing to discuss with triangles. I'll see you in the next lecture.